Hey guys, in this video we'll be talking about the processor status and flags, which it is this value corresponding right over here. So let's get to it. So here we are again with the schematics of the 6502, and if you scroll down over here all the way to the processor status, which is the topic of the video, you're gonna see it's a register, pretty much like the register X and Y, meaning that it is a single byte which contains 1 bit, 1-bit blocks that forms the processor status, and each one of those bits is gonna correspond to a flag, and those flags are set or not set from 0 and 1 depending on the instructions that we use. So it's not something that we can manipulate directly. You need to use these operations to and those operations gonna set the value either 0 or 1. So over here you have the C. This bit represents the carry flag. You have the 0 flag over here. You have the instructions disable bit flag. Here we have the decimal mode. We have the break command. This is the overflow, and this is the negative flag. Which one of this is gonna represent a flag. So let me show you guys the flags in the processor status. Here I have a table of representing the processor status, and like I said, each bit corresponds to a flag, and just like I explained before, I want to C, Z, I, D, and so forth. As you see, the first one, which is the 0th, is the C, and then the second one, which is the first bit, is Z, and so on. But I'm going to go to this order as the 7, which is the most to the list, because that's the exact same order that's on our emulator. So let's start talking about the first flag. Oh, here it is, which is the negative flag. Let me put it over here. Let's type and the negative. Whoops, there's flag. And what the negative flag is, okay, I can bring this over here. The negative flag is set if the 7th bit is set to 1, meaning let's go the same order over here. Let's say, like, if you have 0, 0, 0, 0, 0, 0, 1, which is the same as 1, the 7th most bit, which is this one, it has to be 1 should the negative flag be set. So meaning from 0, 1, 1, 1, 1, 1, 1, that's not going to set the flag. But as soon as you go over 1, 1, 1, whoops, that's too much. 0, 0, 0, 0, 0. I believe that's 80 in hex. That's 80 in hex, so I'll confirm that. But as soon as we go as this value, the flag is going to be set to 1. So let me show you an example. So here we have our processor status, which one is the flag. As you see, it's set to 0, the negative one. So let's do something really fast. Let's load, oops, 80. So if we assemble and run, as you see right away, it's set to 1 or N flag or negative flag. So if we, for example, go 7F, which is the one below, let's assemble, run it. As you see, it's not set to 0 because the last bit is not a 1. So this flag is not gonna be set to 1. So the next flag is the V flag, which corresponds to the overflow flag. And I'll go through that flag with the seek flag, which they kind of similar, and I'll explain the difference of them both. So for now, I'm gonna go to the next one, which is the break command, the B, which is the break command flag. And well, let me type it out over here. B, the break command, and what that does is we're gonna set the fourth, the fifth, or the fourth bit over here to 1 when you use the break command, break instruction. I'm sorry, when you use the break instruction. So when you use it, it's gonna be set to 1, and it is reset when an external interrupt is requested. So for example, something external, if we're talking about the Atari 2600 and the processor wants to, if you press forward or backwards or press the button, the hardware is going to send a interrupt request to the processors like, hey, this is a priority right now. So then it would reset this to a 0. So I can do that for the emulator, so I'm not gonna be showing you guys that for now, but we will be seeing it. And so that's the break command. And let's go to the next one, which is the D flag, which represents the decimal mode. And it's pretty much set to 1 when you use the decimal mode. And let me show you guys what that is. When we're using the decimal mode flag, the processor will obey the rules of the binary coded decimal. So it will be the binary coded decimal, or short for BCD. And what that basically means is from the value 0 to 99, those are our valid legal numbers, and that's the decimal system, so 10, 11, so on. So as soon as we leave that range, it becomes they become illegal values. So but before I show that, let me show something basic, how to do some add operation without the decimal mode. So here I'm adding with a carry, mnemonic for that. Assemble, run, so you get the value 8 in hex, what we expect. But now let's do in the decimal mode, and to do that we're gonna use SED for set decimal, so mnemonic for set decimal. And to get out of it, we're gonna use the mnemonic clear decimal, clear, and then decimal. So if you were to load A, the value 5, so the same thing we did before, and add for carry A5. If you assemble and go to debug, let's step through it. So the first one, you see that decimal flag is on. We got the value 5 on the accumulator, and let's add one more time. And here you got the value 10. On the previous example I just showed you, we got the value 8 in hex. Just showing the processor is going to obey these rules, so it's going to be 10. And if I were to add 6, it would be 11, and so on. But just to keep in mind, let's do something like this. Let's load A, copy over here. Let's assemble this. So well, let's assemble anyway. Step. So load the value 5, got the hex number, decimal. Now let's pay attention for the accumulator over here. And become 15. So just pay attention when you're using this, the decimal mode. So now let's go to the I flag, which is the interrupt disable flag, or the interrupt request disable flag. Let me bring my draw tool over here. So let me just remove. So I, capital I, is equal to, you should see sometimes something like this, just whoops, interrupt request disable. So when this flag is set to, let me bring it over here, when it is set to on, which means on, the program executing is gonna ignore all of the interrupt requests from those outside sources until you tell it, okay, until you set it off. And let me type it over here. So there, you're gonna use the SEI. It's the mnemonic for set interrupt disable. So you're gonna use that on the beginning of your code if you have something that you think that's really important and you don't wanna to be no interrupts requests sent. You don't want nobody choose to stop you from doing that. And once you're done for that important part of the code, you're gonna type the mnemonic CLI, which is clear. Oh, clear interrupt disable. So like I said before, an interrupt request is sent. It can be sent by software or from hardware. Like the example I gave you before is somebody using the controller and press the up button on the computer for whatever reason is gonna send a request interrupt because he thinks that's a bigger priority than you have. But if for whatever reason you are programming and you feel like this part of the code, if you have a part of the code that's the highest priority, so you set it. So you're gonna type SEI for set interrupt disable, and you're done with that part, CLI to clear interrupt disable. Flags is the Z, which is the 0 flag. Put over here. Z equals the, no plus. Z equals the 0 flag. And the 0 flag is set if the result of the last operation that you use is 0. So let me show you what that is. It's pretty simple. Okay, so let's do something really simple and fast. So let's put the 80 hex, which is this value. And by the way, I don't know if I mentioned this before, but this is a semicolon. So everything after this, it's considered a comment, and comments are not part of the program. The assembler is gonna see this are for us humans to read it. So somebody some time will put like a comment over here like, hey, this at 80 hex or something like that. Well, not that obvious, but just you guys let you know. So this will be this value in binary, and then we're gonna do a left shift. What a left shift is gonna do is gonna push a 0 from this side over here. Let me make an arrow. We're gonna push this 0 over here, which is gonna bump this one out of it. So it's gonna, all of this is gonna become 0. So let's assemble. So let's step by step. So here it is, 80 hex, and now the 0 is not set, 0 flag. Let's step. As you see, the accumulator became 0 and the 0 flag is set. So that's gonna be pretty much it for this video. It's getting a bit too long as I'm editing over here, so we're gonna divide this into a second part. The second part is gonna be the carry and the overflow flag, because I need to go through the addition and subtraction with binary. I need to go over the two complements and so forth. So we're gonna sign and unsigned numbers. So we're gonna leave that for us the next video, and that's gonna be it for this. So see you guys on the next one.